Welcome to this explainer. Today, we're taking a pretty incredible journey. We're going to trace the path from writing simple, single-line Python scripts all the way up to building robust, real-world applications. If you've ever looked at complex software and wondered how developers bridge that massive gap from the absolute basics, well, you are in the exact right place. So here's our roadmap for today. We'll kick things off with the Python beginner project's journey, then move into building games with Turtle, tackling GUIs and desktop apps, fetching data via APIs, managing data with databases, and finally, we'll wrap up with some essential tips for improving your programming skills. All right, part one, the Python beginner project's journey. We have to start at the foundation, right? Moving past the boring syntax rules to actually build something fun. The very first stepping stone here is usually something like a classic, text-based Mad Libs game. It's super simple. You just take text inputs from a user and use them to construct a funny little story. But I want you to think about the massive difference in application interfaces here. We literally start our coding journey in a plain, text-only terminal. But by the end of this process, we'll be interacting with visually rich desktop apps, clicking sleek buttons that actually trigger artificial intelligence to manipulate images. It's a huge leap. Which brings us to part two, building games with Turtle. This is our first major visual upgrade, and it usually involves coding something like a classic snake game. This is the exact moment where your code stops being just lines of text on a black screen and suddenly transforms into an interactive, visual experience. Now, to make a game like Snake actually work, we rely on three core Python libraries. We use the Turtle library to handle the graphics and literally draw the snake. Then we need the Time library to control the pacing, because otherwise the game moves too fast to play. And finally, we use the Random library to spawn the snake's food in completely unpredictable locations. The really crucial takeaway here is that we're no longer just printing text out into a void. We're setting up a strict 700 by 700 pixel graphical coordinate system. We're painting the background a vibrant turquoise, establishing a grid, and programming our snake to move exactly 20 pixels at a time, constantly listening for our arrow key presses so it can change direction on the fly. Moving right along to part three, GUIs and desktop apps. We're leveling up again by introducing tkinter to build actual graphical user interfaces. This is where we leave that simple game window behind and start building the kind of native application windows you probably use on your computer every single day. And by combining a few specific libraries, we can build a surprisingly smart tool. We use tkinter for the window structure itself, but the real magic happens when we bring in OpenCV to analyze an image using AI, RimB to magically strip the background out of it, and the PIL library to cleanly display that processed image back to you. With just one button click in our custom GUI, the app processes a photo and saves a perfectly masked version right to your desktop. How cool is that? Okay, part four, fetching data via APIs. Up until now, our programs have lived completely isolated on our computers. Now, we're going to use the requests library to teach them how to talk to the rest of the world via the live internet. If you're new to APIs, just think of them exactly like a waiter in a restaurant. You, the user, give the application your request. The API acts as your waiter, taking that order straight to the server, which is the kitchen. The kitchen prepares the exact data you asked for, and the waiter brings it right back to your app, usually neatly boxed up in a format called JSON. Actually, before handling massive API payloads, you usually master this kind of data translation through a simpler Python calculator project. By building a calculator, you learn to handle basic user inputs, apply mathematical operators using if/elif logic, and most importantly, use the float function to convert string text into decimals so your math is actually accurate. We take those exact same data translation skills and apply them to APIs. For instance, by sending a city name to the OpenWeatherMap API, our app pulls raw weather data, translates complicated meteorological coordinates, and formats it into something highly readable, like turning raw numbers into simple wind directions like north or southeast. But a quick pro tip as you step into the world of APIs. When you're using free tools, like the Unsplash Image API you might use for an image fetcher project, you're usually capped on how much data you can ask for. In that specific case, you're strictly limited to 50 requests per hour, so writing efficient code becomes absolutely crucial. All right, section 5, managing data with databases. We have officially reached the ultimate boss level of beginner programming, permanent data persistence. We've built games, we've built interfaces, we've talked to the web. But what happens to all the information we generate? Seriously, think about it for a second. What happens to a user's progress or a store's inventory when the program actually stops running? In a basic script, The moment you hit that X on the window, all that data just vanishes into thin air. For a real-world application, that's literally a disaster. The hero of the story is SQLite 3. It's an absolutely incredible, lightweight library that's built right into Python out of the box. It lets us seamlessly create a database file, connect to it, and save our data securely in organized tables. That means all of your users' information is right there, waiting for them the next time they open the app. To put that into perspective, here's how a supermarket application structures its backend database. By assigning every single item a unique identifier, which we call a primary key, we ensure our app can reliably locate, update, or remove any product. So it never mixes up a box of pasta with a bag of chips. With this database running in the background, our supermarket management system can handle complex operations just like a physical cashier's checkout screen. We can add new stock, automatically deduct quantities the second an item is sold, and even generate a dynamically calculating billing receipt before the transaction closes. You can even take this a step further with a simulated ATM project. You can combine the random library to generate secure dummy card numbers, use the datetime library to automatically set a 5-year expiry date on new accounts, and then push all of that into your secure SQLite 3 database. It creates a deeply realistic banking backend that ties everything we've learned together perfectly. Finally, Part 6, Tips for Improving Programming Skills. As we wrap up this explainer, let's talk about how to make all these concepts actually stick in your brain. Watching these projects come to life is awesome, but becoming a real developer requires you to take action. The absolute most crucial piece of advice I can give you is this. True understanding only comes when you stop blindly copying and pasting tutorials. You have to write the code yourself, line by line. Tinker with the parameters, break the logic on purpose, read the error messages, and figure out how to fix them. That right there, that is where the real learning happens. So now that you've seen the incredible progression of what Python can do, from those simple text-based games all the way up to GUI-driven, AI-powered, database-backed applications, the ball is entirely in your court. What unique feature are you going to build into your next project? Get out there, start coding, and make these tools your own. Thanks for joining me on this explainer, and happy coding!